that'll be a regression model. So you're trying to predict the speed that you should go at based on the speeds of all the cars around you. So you have the sensors on the top of the car or in certain locations where you can measure the speed of all the cars around you. That's one part, to maintain your speed. And then also when to stop or not along the, let's say you're driving on the road. Also when to get off the highway and how to look up at the images that we have, right? That, okay, this is exit 127, so take that. So now they will have the GPS set up here. The GPS is telling the car that you should take 127 exit, which goes to Morrison Road. Now, the car will look up at the image that's going to show up near to the exit, and then there will be image classification happening there. So they're going to classify what is written on the on that sign, and then it will read that out, and then it will decide, okay, is this the 127 Morrison Road turn, and then it will take that. So many things that are happening at the same time. This is really surprising to me. And so there's a reason they have all these cars running for years now, because you really want a lot of data from all angles around you to be able to train the model and then have the car run very smoothly. So to me, I think this is the most surprising, because there's so much happening at the same time, and we have this right now. So the next step people are talking is that everything is going to go autonomous in like 5 years. So when you're, let's say, driving from here to Colorado for a vacation, the screen is going to be an Apple TV. So there will be no screen because the car is autonomous, so you will be watching Netflix over there along the way, or play games or do whatever. So the travel is going to change considerably the way we perceive it right now. It will be more enjoyable or less tiring for the driver. So that's the most surprising, the most interesting, or the one I like, I think, natural language processing. I think I really like that personally, to be able to do a bunch of things, simple things. We're not that far off here, only simple things, but still I think it's useful. And also image classification, I think. Image classification is huge for different reasons. One is the use in medicine. I think it has really helped in medicine, that when you work with medical images like chest x-rays or the tumor images, and to be able to classify better than the doctors have been on average. So the classification in there is very surprising, very interesting, and I think that's a good progress. Good question. Anything else? Yes?
What do you hope to be doing after you get your PhD?
I like teaching more. So I am aspiring to get a teaching position at a research school, hopefully as a professor. However, recently I'm really interested in the deep neural networks. So I plan to work on the applications, learn more about them, how to implement them. This is a very simple neural network. This is a feed-forward neural network. There are very unusual kinds of neural networks out there which are being used in practice. So I want to learn more about them and possibly use that in a practical setting. So let's say for medical imaging. So consult with a medicine school or hospital to help them get better models. So I would like to explore some practical applications, but my aspirations right now are to work as a professor. Great question. Anything else you guys would like to ask me?
Yes.
You mentioned like supervised and then unsupervised learning, and you said there's a third one. So is it possible to briefly describe what that is?
Sure, yeah, that's a good point. So the third one is called reinforcement learning. The idea is that you learn by playing the game. So you say whatever situation you are in, so let's say you have a robot, you want it to learn something. You want it to learn how to get out of the door. If you have a robot which is in the room, the door is closed, you want to make it learn how to get out of the doors, or how to get out. So you push the lever down, and that's how you get out. So you want the robot to learn all of these steps by itself. So the way you do that is you will let it try. You will let it try, and it will, let's say it knows how to walk. So it will walk there, and then it will try to do something. You let it try a couple of things at first. So you let the robot explore first, And then it will realize I'm not getting out, so this is not a good strategy. So then he will rule that out. Then he will try to do new things. So the new things you will be telling them. So you will be giving the agent, so we call it agent, whatever we are working with in a gaming environment, in a real world environment, a robot, you call it an agent, and you let the agent do different things and then learn from itself that this is not working, I'm not getting the reward that I'm supposed to get by getting out of it. So you write down a function called reward function. So we have the loss function that we're trying to minimize. In that case, you will have a reward function that you're trying to maximize, and it will be maximized only when the reward gets out of it. So it learns by doing things. So it learns by exploring. It learns by interacting with the environment around it. So this can happen in games. So that's the hot topic right now. That does anybody here play games, video games? What kind of games?
Shooter games.
Shooting games. So you want to have a virtual player playing the game very well, to be able to shoot very well. So that'll be your agent, and the reward he gets is when he shoots people. So the more people you shoot, the more your reward is, and you give them all the possible options all the possible actions that he can take at that point. And then you let the system run, and then you see how quickly it learns that, okay, if this is not a good idea, if I'm shooting to the ground, I'm probably not hitting anything. So then you let it, so there's a lot of what we call exploration. So you call exploration. So you let the agent explore a lot. So there's one thing which is exploration. There's another thing that by your personal experience as a human or playing that game, you would know some average greedy strategies which will work. So that's what they call expectation strategies. So now the issue is that if you only do the average thing, the expected stuff, the reward might not be as great. So you want to explore a little bit. So you want the agent to try different things and then learn by itself whether this is worthwhile or not. So there is this going back and forth between exploration and expectation. So right now the research, a lot of the reinforcement learning is happening with respect to the gaming environment. So people are playing different games, shooting games, Mario Kart. People are playing that to learn to let the Mario learn. Okay, what are the good strategies to move ahead, forward, things like that. So that's the new thing, reinforcement learning. So that's like your agent learns by interacting with the environment, and there are two options. Either he can explore a lot, but the issue is that there is so much to explore. There are practically infinitely many options you have. So how do you come up with a better strategy to get the best you can? You cannot do brute force. You cannot go through all of them, but because there are infinitely many of them, so you cannot do that. But you want to find a nice balance between exploration and average strategies to make it work. So that's the reinforcement learning. That's very new. So you're trying to learn a policy, a set of actions that your agent should take at each step to maximize the reward. So if it's a player playing a shooting game, you want to take actions at each step of the game where you maximize the kills.
Well, let's go ahead and thank Hassan for his presentation. I'm sure he'll stick around for a few more minutes if there are other questions. I'm
Sure, yeah.
happy to talk to folks.